Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. So in this video we are going to discuss another very important concept, which is thermal expansion of solids. So what is thermal expansion? So when any object, okay, it is heated, it is subjected to heat, there is a change in the size of the body or the object, okay, and normally it increases in size. So this phenomena of increase in the size of a body or an object when it is heated, that is called as thermal expansion. And all solids, liquids and gases, they expand on heating, but thermal expansion of liquids and gases we'll discuss separately. This is mainly thermal expansion of solids. So this expansion, it can be, this increase in size can be categorized in three ways. First is linear expansion, which is one dimensional expansion, okay, in one way, okay. So this is in terms of length, okay, linear expansion, the expansion or change in size or increase in size in terms of length. Then we have surface or superficial expansion, which is two dimensions, okay. So this is in terms of surface area, okay, increase in surface area on heating. And then we have volume or cubical expansion. So this is three dimensional, it is in terms of volume, the increase in volume on heating. So three types. Now before we discuss them in detail, let us just try to understand very quickly why solids, they expand on heating. So here we have to go into their molecular arrangement or atomic arrangement. So we know that in any solid material, okay, in any solid material we have atoms or molecules which are held together at fixed distances, okay, interatomic or intermolecular separation, which is the equilibrium position of those two molecules or atoms, which are held together at fixed distances by forces of attraction. Now when it is subjected to heat, these atoms or molecules, they start vibrating or oscillating about their equilibrium position, okay, like this. They go away and then they move towards each other. So as a result of this oscillations, these vibrations on heating, the intermolecular or interatomic separation, it starts to increase, okay, like this. So this results in the expansion or increase in the size in terms of length, in terms of surface area, in terms of volume. This is the basic reason. There is a lot of other things to it, but just for now you keep it at this basic level, okay, without complicating things. So in this video we will be discussing about linear expansion, okay. So let us say we have a rod, okay, which is at an initial temperature Ti, okay, and it has an initial length of Li, okay, initial length Li, initial temperature Ti. Suppose it is heated, it is subjected to heat and it acquires a final temperature of Tf, okay, it acquires a final temperature of Tf. So here the change in temperature, it is final temperature minus initial temperature, Tf minus Ti. Because of this heating, it undergoes linear expansion. Okay, so its length, it increases from here to here. This is the increase in length. This is the increase in length. So the increase in length, that is given by final length minus initial length. Okay, increase or change in length. Now here it has been found that this increase in length, okay, this increase in length, it is directly related to some factors. First, it is directly proportional to the change in temperature. Okay, it is directly proportional to change in temperature. So the more change in temperature, the more the change in length. And also it is proportional to the initial length. Okay, the initial length. So when we combine these two factors, we get the change in length or the increase in length is directly proportional to Li delta T, that is initial length and change in temperature or increase in temperature. So we can write change in length is equal to, we will include a proportionality constant here, alpha Li delta T. This is the expression for linear expansion, where alpha is the coefficient of linear expansion or the linear expansion constant. Okay, this. Okay, this. The change in length is given by this, alpha Li delta T, directly proportional to the initial length, directly proportional to the change in temperature or increase in temperature, and alpha is the proportionality constant. So the final length, it can be given by initial length plus increase in length or change in length, that is equal to Li plus alpha Li delta T. From here, this is the increase in length, this factor, this is the increase in length. So we add it with the initial length to get the final length. So that is written, we can write it in this way, taking Li common, Li into 1 plus alpha delta T. Now this linear expansion coefficient, that is given by alpha is equal to delta L by Li delta T. Okay, alpha is equal to delta L, Li delta T goes to the denominator on the LHS side. Okay, delta L by Li delta T. It has units of degree Celsius inverse or Kelvin inverse, because in the numerator we have length, in the denominator also we have length. This is change in length and this is initial length, both have the same units. So we are only temperature, whether in degree Celsius or Kelvin, in the denominator. So it has units of degree Celsius inverse or Kelvin inverse. So this is linear expansion. Okay, so again we have discussed here linear expansion. The cause of it is when it is heated, the vibrations or oscillations of the molecules or atoms, they increase the average interatomic or intermolecular separation, which is generally greater than the equilibrium separation. And as a result of this increase in separation between atoms or molecules, the object, it undergoes an increase in size, here in terms of length, in one dimension. So here if you notice, the change has happened, the increase has happened only in one direction. Okay, so this is the thing. So here we have discussed about linear expansion.